Hello dear friends, welcome back to Tech class. This is Prabhavati Kundargi. So today in this video we will study about the Sylow's third theorem. Okay, shall we begin? So let us see what the Sylow's third theorem says. Okay, number of Sylow P subgroup is equal to 1 plus Kp such that 1 plus Kp divides order of G, where K is equal to 0, 1, 2, so on up to that, and P is equal to 1 plus Kp such that 1 plus Kp divides order of G, where K is equal to 0, 1, so on up to. So why we have to use the Sylow's third theorem and why we have to do means for finding the number of Sylow P subgroup. Okay, so in the previous lecture we have studied about the how to find this P subgroup and how to find the order of this P Sylow subgroup and these all things, right friends? So in this video now we have to find that one, how many number of Sylow P subgroups are possible. Okay, so here why we have to use this one means for finding the number of P Sylow subgroups. Okay, so how we have to find this means, just look at here. If 1 plus Kp divides your order of G, okay, if 1 plus Kp divides order of G, then you can say this 1 plus Kp is a what? So this is nothing but this gives you a number of Sylow P subgroups. Okay, so just look at here and we will study one examples, then this concept will get clear to you. If order of G is equal to 14, how many 2 Sylow subgroup in G? Okay, so here what they have asked, they asked for us for finding the number of 2 Sylow subgroup. Got it? So why we have to use this one means for finding the number of 2 Sylow subgroup, or like a P Sylow subgroup. That P denotes what? Prime number. Okay, so let us see what is the first condition or what is the first step. What we have to do means, just as it is, first write the order of G. Okay, so it is the order of G, so that is nothing but what? 14. Okay, so what is our next step? In the next step we have to convert that 14 in the product of prime number. Okay, 15 can be converted into 2 into 7. Okay, 2 times of 7. So just look at here. So here we have a 2 Sylow subgroup as well as 7 Sylow subgroup, right? So they asked for us only for finding this 2 Sylow subgroup. Okay, just look at here now. 2 to the power 1 divides 14. Okay, but 2 to the power 1 plus 1 doesn't divide 14. Therefore we can say that 2 Sylow subgroup of order is what? That is nothing but what? 2. Okay, so now we have to find the number of this 2 Sylow subgroup in G. So it is the formula, that is nothing but 1 plus Kp. Okay, so what is that P? So that our P is what here? Our P is prime number, that is 2. Okay, P Sylow group means what? Here our group is what? 2 Sylow subgroup. So therefore I am going to keep here 2. Okay, 2K. So now let us check. Okay, if that such that 1 plus 2K divides this order of G, and so this is what now? This is, I just keep this one as it is, and this is what I just applied the formula here. Now we have to keep K is equal to 0, K is equal to 1, K is equal to 2. It means just put the K values, different K values, and check whether this 1 plus 2K divides order of G or not. Okay, if it divides, then that gives you a number of P Sylow subgroup. So just look at here. So this is what? This is our formula, and first I am going to put a K is equal to 0. If I put K is equal to 0, then it will become what? 1 plus 2 into 0, which is equal to what? 1. Of course 1 divides order of G, right? Then my N2 is what? So that is nothing but what? 1 is possible. It means number of 2 Sylow subgroup is equal to 1 is possible. Okay, so now put k is equal to 1. Okay, when you put k is equal to 1, then you will get your n2 as a 3, but 3 does not divide this 14. Therefore, number of p 3 is not possible here. Okay, number of p Sylow subgroup of 3 is not possible. Now let us put k is equal to 2. Okay, so if you put your k is equal to 2, then you will get your n2 as a 5. 5 also doesn't divide 14. So therefore n2 is equal to 5, which is not possible. Okay, so now put k is equal to 3. If you put a k is equal to 3, then you will get your answer as a 7. Of course 7 divides 14. Then n2 is equal to what? 7, which is a possible. Okay, if you put k is equal to 4, then you will get your n2 as a 9, but 9 doesn't divide 14. Okay, therefore n2 is equal to 9 is not possible. So check for this 5, 6, 7 for those all case which is not possible. Okay, therefore then the number of 2 Sylow subgroup in G is what? Either n2 is equal to 1 or n2 is equal to 7. Okay, if they asked you for in a multiple choice options, like the option is only 1, then you have to choose n2 is equal to 7. Okay, if your option is more than 1, like in a part C, then you have to choose these both answers. Okay, and you might ask until when we have to take this k value, means you have to take that k values. It means so here this is what, this is our numerator and this is a denominator, right? So here we have our order of G, and here what we have, here we have a 1 plus kp. Okay, you have to put k values and you have to check until this one is what, this is your denominator. Okay, until denominator is greater than numerator. When you will get a denominator is a greater than numerator, then you just stop and write. Okay, if for any k is not, if you put so many k numbers like 1, 2, 3, 4 and these all, if it is not possible to divide, then you have to put a k is equal to 0. Okay, it means what, if you put k is equal to 0, then what you will get, you will get your answer as a 1. Okay, so this is what Sylow third theorem says, guys. Okay, so this is the most important topic, this is the most important examples in your CSIR as well as NET exams. Okay, sometimes they'll ask for part C, sometimes they ask for part B also. So just keep remembering this formula. This is very simple. Okay, solve more problems. I hope this video helps to you all. If you like the video, give a big thumbs up and don't forget to share with your friends and your colleagues. Okay, see you in our next lecture. Until then, take care. Bye bye. Thank you.